This is sort of the second half of a pair. There's platforms and profiles that started yesterday with Greg Favor in the keynote. And when we first started, we had 10 minutes for everything, and somehow we got an embarrassment of riches and ended up with 20 on the keynote yesterday and 25 here. So this is going to concentrate primarily on platforms. I'm just going to spend a couple minutes and then hand it off to Philip. I really, again, the profiles, just to tell you motivation, the profiles are really to stop fragmentation in the ISA, in the software ecosystem. Because, without some compendium of instructions or extensions together that we tell the world works, people are going to go be bugging the upstream projects and the distros to all go do different things. We don't want that, right? It's the number one question I get asked by press. How do you stop fragmentation? Well, first, you have to tell people what you want, right? And that's what profiles and platforms are about. But the second thing is the bumper sticker statement that I always tell people, innovate, don't duplicate. And that's really what keeps us together. The whole reason for a community is we get to share all the ecosystem work, all the architecture tests, all the other things. There is no other reason for us to be together, right? The goal is to take the things that we've all done 1,000 times before. Why do you have to do addition, subtraction, multiplication one more time in an ISA? Why do you have to do it one more time in an upstream project, in a compiler, an optimizer, and so on and so forth? We share. So the profiles, again, Greg talked about that quite a bit yesterday. That's about instructions. It tells you what the requirements are for the software ecosystem and for the hardware. What has to be mandatory, what is required, what is optional, so on and so forth. Then we go on, and I'm going to skip this. And just for platforms, I just want to tell you, there is a huge amount of work that has gone on over the last year. Kumar's here, he's driven the platform team. There's been a whole host of people, but if you take a look at the dependencies, and I'm not sure if you're going to show that later or not, Phil, there's plicks and clicks and clints and SBIs and ABIs and discovery and so on and so forth. The idea there is if you have a distro and you go ahead and create a set of bits, folks can download that from multiple implementations, do a standard kernel config, and be able to go ahead and just run it. Again, this is a fragmentation reduction topic. That's why we do this. This is so that we don't drive the distros nuts. If you've been watching the rhetoric in some of the online forums and stuff, there's worry about that. When are we frozen? When are things complete? When can we tell the upstream projects to do things? This is answering that. Ultimately, we have two goals. One goal, take an application from one implementation to another and have it work with similar results, excepting, of course, things like timing and other stuff. And the second is be able to take a distro and be able to run it on multiple implementations. This reduced the costs in the world of supporting RISC-V and allows us to behave like all the wood behind one arrow. So with that, that's kind of the motivation. That's why we're doing this, and an exciting amount of work. I'm going to introduce the main speaker here. He's going to go into detail, and that's Philipp Tomsich, and he's from VRULL, and he and I met probably about a year and a quarter ago, and he stepped up to be the vice chair for software, and then when the gentleman who was the chair stepped down, Philipp stepped in. When Philipp started, there was really basically one group under software. There's now about 15. A lot of them are SIGs. SIGs are how we handle continuity. So everything from graphics to Android to discovery to some of the platform subsidiary things, hypervisor on the software side. Philipp's helped make that happen, and we're really lucky to have him. He's really helped the community, and we're very grateful for that. And with that, I'll hand the podium to you and take it from here. Thank you.
Thanks, Mark. I'll start talking right after the blush goes away from all the compliments. So I'll skip back a bit because Mark set this up quite nicely in terms of what we're trying to do. And I will actually go into the growth of software into software HC as well. And that more on the end, because platforms is really a bigger topic. Platforms is not just compatibility. Platforms is forward-looking. Platforms is giving implementation guidance and improving the user experience and enabling an off-the-shelf market. So one of the problems that we really have is that people are starting to say, are you guys nuts? Bitmap has fallen into 4+ extensions. Vectors isn't one extension, but multiple. So the fact that we have a modular instruction set, what we're trying to deal with on the profile side as well, is really troublesome to some people. I could say it's beautiful. It's a fully connected graph at worst in terms of combinations that you can have. The only problem is too many options. And that is being captured on the ISA profile side today, where we're having the basis, but that still doesn't give you something where you can just plainly install software on. And part of the challenge that we have as an ecosystem, part of the challenge that the software HC is trying to address is not regulating. We aren't trying to make sure that all cucumbers have the same shape and the same size, but what we're trying to do is we're trying to establish one platform or a couple of platforms that you can go buy hardware that is compatible with it from Amazon, download the software distribution from your OS vendor of choice, and the two should just go well together. This is important for the makers, this is important for hobbyists, this is even important for us in lab work when we're trying to prototype and build something up. We're in no way with this trying to regulate. People can't dedicated applications. So if you're building a car, nobody cares if you have that. If you're trying to build the next Bluetooth headset, nobody cares about platforms. But platforms is a tool in order to make life of the engineer and the casual user easier when they're having to deal with off-the-shelf platforms and off-the-shelf software. That is quite critical to us for a very simple reason, because we're trying to build a software ecosystem. So we need independent software vendors, we need OS distributions, and we're trying to enable software being created at this point. So we're trying to manage the complexity that RISC-V brings with all of those variations and manage it in such a way that software engineers can relate to it. So what platforms are, that was part of what Mark was trying to describe. It's something where you can take software and put it on hardware. And that is, however, not very well defined yet. This is just a strategic goal. And what the platforms group has been working out in large part over the last year is how that translates into actual specifications. Do we mandate things for M mode, S mode, U mode? What do we need to put in there? I was part of a discussion yesterday afternoon here about where a system call API needs to be standardized. If we need to standardize calling conventions at all, or if they should go into separate specifications. And that is because a platform is different depending on what you're trying to do. So if you're deeply embedded, you might be more worried about source code compatibility. If you're trying to run a Linux distribution, you just want that installer and the kernel and the rest to run reliably and without much fuzz on the platform that you have. And the biggest and most important part of it at this stage for us is that we define compatibility, compatibility in such a way that people simply can make their use cases work. And these use cases will be different for embedded, for server, for your desktop, and eventually for other markets like HPC. So really briefly put, a platform is something you take platform compatible software and whatever that means for that specific platform, and you take platform compatible hardware or platform compatible implementation, put them together, and it just works. In In order to do that, what we have to do is we need to take all of that variability that we're creating in RISC-V. We're very proud of creating that variability and make it more specific. So we're having sort of a specification funnel. This isn't entirely accurate because it doesn't capture the fact that uncore components, that we're having ISA components, that we're having profiles. But it is a simplification in order to better understand what's going on. So we're having this extremely modular instruction set architecture, RV32, RV64, all the extensions. And we're taking those in as a base level. We're creating profiles on top, but for us on the platform level, profiles are just groupings. So actually profile is just a fancy name for some selection out of the instruction set architecture. We're also taking in our non-ISA specifications. PLIC, CLIC, ECLINT, and have been driving an entire new interrupt architecture because we needed to go with the platform. So if you have a rich operating system, you'll have virtualization capabilities. We're bringing the H extension in, and now what we need are dependencies or satisfy the dependencies that we see as we put the platform together. We need an virtualization aware interrupt controller. We will need an IO MMU, which is another initiative that's being started at this point. In order to tie those together, then add a few software specifications, like how do our runtime services look, UFI. And as we bring all of that together, we can define these mysterious platforms. So a platform is really something that gives us some level of similarity between platforms. And in the case of Linux or a rich OS, this is going down to the ISA level. This is going down to the runtime services. And if we're embedded, it might just be APIs. But it gives us a very specific solution, one that is so specific that we can reuse it. There are some compatibility goals attached to that, and that's another difficulty or another challenge that we've been addressing. So unlike profiles, we're not trying to do a yearly cadence. The goal for platforms really is to be biannual, so people have time to adapt to it, to get their software going. Changing the platforms every year, doing a major revision, would just create more effort that doesn't really foster adoption. If people implement something on the platform, should also have a chance to deploy it and learn from it before having to target the next one or trying to do so. And even if we bring out the next platforms, we don't want to break things. So forward compatibility is one of the major goals of the platform specifications. There's only one problem. If you're perfectly forward compatible, you stand still. So at that point, we had to thread the needle there, and we came up with a scheme that sees exactly two cases where we'll be breaking forward compatibility within a given platform. One of them is security. I mean, you can't argue with security. If we did something that needs to be fixed because we need to close the security hole, so be it. A second one is we want to foster long-term evolution. We know what's going to happen, but that means we will be deprecating features. A good example is, and that may sound weird, because we're starting with our first specification, having some components in it that we don't really want to carry forward. One of them is PLIC. We're having AIA as an alternative, but it was coming in too late. So we're starting with that component is deprecated, which is one of the few components where we don't give a 4-year window until things get removed. So when we're saying a feature is deprecated, it means it can be removed already in the next major iteration. The next major iteration is 2 years. If something is just a mandatory requirement, that requirement is still going to be there 2 years from now, at least in deprecated state. So the earliest we're going to remove things is going to be 4 years down the line. On the other hand, backward compatibility is a goal we have, But again, we can't just put it into the specs. If we did that, we'd be static. If we wanted to guarantee both forward and backward compatibility, every spec would have to eventually read more or less the same, or we'd be adding more and more requirements. Instead, we're pushing that out to software. So backward compatibility is something that software can very easily achieve by doing dynamic probing, reading the configuration tables, and so on. So what is coming? What is coming for 2022? And at this point, we have settled down to very achievable. I guess the people who've been in the calls are going to have a good laugh at that, but still a very achievable subset. It's only a draft now, because even though it's very achievable, it isn't easy. And that is going for what we call OSA. OSA is operating systems on application processors. To be entirely honest, it's the former Unix spec. So it's Linux and BSD with a neutral name and something we can build on also for other operating systems in the future, hopefully. We're going to have a base spec on there, which might be called embedded, which might be base. So things are a bit of a moving target in terms of nomenclature. But this is really your basic system running Linux, a single board computer, an embedded gateway device, an IoT gateway, something that you can install a Linux on. And the second platform is what we call the server platform, which isn't just for servers though. Network appliances, anything higher end that needs virtualization falls into that category. So your storage server might be a server class system, even though it's a network attached storage. And the goal for both of these is that we want binary Linux distributions to just work. I mean, the same goes for BSD, but the level or the way we're discussing it mainly in the groups is asking what would the Linux distros want, what would the Linux distros do, because there's multiple of them. It's a market, it's being driven by them. While BSD is a very vibrant ecosystem that just interjects when they see something that doesn't fit and get our specification work corrected. On the other hand, there's going to be something for the low end as well. OSA, big machines. On the other hand, we are coming out of embedded, and some of the other ecosystems have done great in creating some level of adaptation layer, portability help. I mean, it's never easy to port from one system, but you can provide an abstraction layer for your UART, your GPIOs, your vector, your interrupt controller, and that's exactly what ARM is providing, for example. And given that we have that huge set of variants on the profile side, even we've heard that yesterday. So the M profiles, there isn't just one. There's plenty. And we can't really tell people, okay, you have a 64-bit microcontroller from here forward, and anything else is not supported. We have to step back from actually mandating these details. That makes it incredibly hard to provide binary compatibility. Actually, it makes it impossible. So on the embedded side, what we are defining is a common software interface, something that will be API compatible, will give you basis for porting. Yes, there will be fragmentation because vendors will have their own extensions. You might use vendor libraries, you might use vendor features, but at least the core logic, the basic code that you're writing should be portable. So binary compatibility on the high end, source code compatibility on the low end. Let me dive a bit deeper into OSA. So Mark already hinted at it. This is probably the most entangled topic that you will encounter in all of RISC-V. I do envy the people who specified vector because they had such an easy and well-defined problem. So we are having the profiles on the one hand, trying to push things in, accelerate adoption, even with extensions that are coming in late, like vector. What do we do with vector? It's only going to be optional at this stage. Even though we'd like to have it there because it's a direction. We want to have SIMD capability. We want that in our high-end platforms, but we can't mandate it because when is it going to be available? So we need to have that transitionary model in mind in anything we specify. We're having the profiles as one of the dependencies or one of the complexities and one of the things we cover. But also interrupt controllers. Starting the profile work, everything looked fine. So there was one interrupt controller that was mostly used, sort of, kind of, but not exactly specified, which was Plick. We fixed the specification issue, but that didn't really get us over the point of what do we do with age and virtualization, given that there is a push towards servers. So as part of that, we had to motivate getting a group started, and that group has specified the advanced interrupt architecture. We have unify runtime services as a big topic, one that is coming up over and over again because it allows us to boot, to install, and also to write to a diagnostic UART. Discovery processes are playing into that. So the platform group and the software HC together with platforms has been driving the definition of our unified discovery. There were multiple discovery mechanisms. There are plenty of discovery mechanisms, and we've even been talking about the WRL semantics yesterday on the keynote stage for a moment. So all of that can be addressed by software, but we're trying to bring people to the architecture. We're trying to give them a more unified view, and that's why low-level discovery processes are playing into that. Yet on the server side, for example, we're also translating into higher-level processes like ACPI. Virtual memory, of course, a big concern. The anti-cache management discussion was playing into this, and platforms was one of the groups driving the standardization of cache management. Because again, you want an operating system on there, you'd better have one way of doing your cache management and of specifying your page-based memory attributes. The system timers are going in there, watchdog timer, another specification written by that group, and the PMU and ASET support had to be folded in one way or another, given that this is a requirement for the high-end applications. So just in terms of coverage, and this is just a snapshot, so tip of the iceberg, this group has really been touching on everything, and that was with small membership and even fewer contributors. I mean, come on, you're in the middle of the room. How many people were actively writing that spec? 20? 20. So actually, we had 20 people give up a good part of their life over the last year in trying to dig through all of that, figure out what third-party specifications we could reference, what third-party runtime services we'd want to have, and drive that forward into a document, and also move forward with having it reviewed by all of the major Linux distros at this point. Since I said we're touching on everything, everybody's making our life difficult at this point. So in order to finish the platform specification, and I'm not even getting into platform compatibility testing and achieving definition of done, we are dependent on a long list of documents that need to be there and a long list of specifications. So we need the profiles. Footnote, they're only in draft right now. We can't even finish because we need ratified profiles. The advanced interrupt architecture. Another group that is having a major work effort, that is having a ratification cycle. And before they aren't ratified, we can't be ratified. The advanced core local interrupt controller coming out of it, the old platform level interrupt controller that wasn't an open specification up to that point. But multiple companies having implemented exactly the same, so doing a reverse specification approach on that. And then goes down, PS ABI. We started a task group under toolchains and runtimes in software in order to move that forward. This is one of the documents and one of the specifications that's currently being frozen. There's a draft of an ACPI extension for RISC-V now that's out for public review and being fed back to the consortium. And it just goes on and on like that. So really, once you're trying to define a platform, you're doing catch-up on everything in that area. So how does our projected timeline on this look? I'll be entirely honest to you, those are projected dates. Projected as in, if the groups get the homework that's still left to be done, completed on time. If we make it through the internal review cycles, then we have a chance of actually freezing this in Q1. We are having all of the dependencies there, but it is our top priority on the software side. There's a reorganization of the platform HSC pending because we need to create task groups underneath. We can't have the HSC do all of it, but we're not going to touch them because they are really at the heart of this effort. And if we don't get this out, then the ISVs, then the OS vendors and the server vendors won't know what to do. So this is our top priority. We're working hard on it. Any additional resource wanting to contribute there, please reach out to Kumar. He is the chair of the HSC, of the platform HSC. We're looking for volunteers to cross-read it, to contribute to it, to add rationale where we've missed rationale in the hurry of getting it done. And on the CSI, we're aiming for a freeze late 2022. This is a bit better controlled. This is a bit easier, given that it is a smaller topic and just source level control. We've completely paused it for the time being, but this is going to be resumed as soon as OSA is in a good status. And finally, a quick outlook, because I'm being that asked frequently, more on the leadership side within RISC-V than by the community. But we aren't going to stop. We'll have OSA, we'll have this basin server. We have created the extension mechanism in order to actually have a distribution or platform that has an additional feature. And we're talking to the HPC groups. They are well organized, they have great talent to actually help us define an HPC platform. This is going to have changes to virtual memory most likely. This is going to bring in vector support already as an extension. And a second one is secure boot. So secure boot is a big topic. The distributions are interested. We're trying to not make the same mistakes that other ecosystems have made, where the SoC vendors were defining their secure boot headers, some of them more successfully than others. But we have a very strong security constituency within RISC-V. We have the security HC, we have the distros coming in. And that really gives us a chance to do it right, to define one secure boot header format, one secure boot format, and bring that in, maybe have two different variants for OSA and MCSI, but bring those in and have secure boot very early. And given that I like these quotes, just one thing. In this case, with the platforms, we will be going out with something where we know it is not the end of the road. So we're really working hard here to establish a blueprint of how platforms will look, mechanisms, and we're fully aware that what we'll be putting out as an OSA 2022 platform is not going to be the final one. But we need to get it out because otherwise we'll be forever caught up in these discussions. We'll never have the final one. Instead, we really need to push one platform out as a foundation to innovate on. And if that innovation is a 2024 version, or actually an entirely new platform that we do next to it because we have learned, that is fine. Just one last thought. I'm already getting the 1 minute warning there.
That's the 1 minute over warning.
I'm interpreting it any way I want. So platforms also has another pitfall, and that is testing. So we need to provide our vendors with some way of actually ensuring platform compatibility. But you've seen everything that we're covering in there. We can't test all of that. Yes, we can ask them for the ACT tests, but we need to still test our entire external surface of the platform. So we will be heading for self-attestation first, but implementers will really need to do their homework. They will need to add to those tests that we can define. They should implement their own tests and run them in order to get a high degree of certainty. And I can only ask them to contribute back. The platform compatibility testing effort hasn't even started. We haven't even written the policy yet. But this is something that is going to start around the time when we freeze. And once we have the manpower and the brain power again. And when that happens, we can only do something incomplete, unfortunately. So people will need to do their own due diligence. But I really ask everybody who does some testing at that point to contribute back. And one final word, there will be branding. It's not final yet, but it's going to be along the RISC-V compatible line, like with the profiles yesterday. So it's going to be RISC-V compatible with the OSA platform, the OSA server platform, the MCSI platform. And that's how you will recognize that you're having two products that should go together. Mileage may vary.
All right, let's give Philipp a round of applause while he breathes. We did get a couple good questions. I would encourage people to reach out, find Philipp, because we're out of time and it's lunchtime. Find Philipp, offer to help, ask him any other remaining questions. But thank you very much, Philipp.
Yeah.
Well done.
Just one thing. Kumar, could you get
Yeah,
up?
stand up, Kumar. Let's clap for Philipp and Kumar.
So Kumar has been moving this along, and please also reach out to him. He's always looking for help in the platform HSC. And we wouldn't be where we are without him.